Good day, my name is Jesly of Murcia from STEM 104, and this is my task performance in basic calculus. So the topic that I chose is a limit of a function. Before I proceed to the example problems that I prepare, let's first find the definition of limit of a function. So it tells the value that the function approaches as the function's inputs get closer and closer to some number. So the idea of a limit is the basis of all calculus. So now that we knew the definition of a function, now let's proceed to the example problems that I prepare. Now we have here limit as x approaches 5 of a function x squared minus 5 divided by x squared plus x minus 30. So although the limit in this question is the ratio of two polynomials, x equals 5 makes both the numerator and denominator equal to 0. So we need to factor both numerator and denominator. Yeah, we need to factor it. So limit as x approaches 5 equals to and then now we simply obtain it. So it's equals to limit as x approaches 5 is, and so this is the answer. Yeah. So 10 over 11 is the answer for limit as x approaches 5 of a function 2x minus 5, 2x squared minus 5 over x squared plus x minus 30. I have here limit as y approaches 7 of a function y squared minus 4y minus 21 all over 3y squared minus 17y minus 28. So let's just simplify and recall the basic ideas for computing limits that we look at this section. Okay, so first let's evaluate the limits of the numerator and the denominator separately. So limit as y approaches 7, y squared minus 4y minus 21. So next is evaluate the limit. So in this part we can see that it's 0 over 0. So that's the answer. But we can't like accept it because it's undefined. So that does not mean that the limit doesn't exist. We'll need to do some work before we make that conclusion. All we need to do here is some simplification. So okay, so let's try to write negative 4y as a difference. So limit as y approaches 7 is plus all over. Let's try to put this as a difference. So next is, let's try to write negative 17y as a difference also. So 3y squared plus 4y minus 21. Next is factor out. Factor out y from the expression. So okay, now let's factor out y plus 3 from the expression. So okay, now let's factor out y from the expression. So that means limit as y approaches 7 is equals to all over yx 3y plus 4 minus 7. As you can see, I just factor out the 7 expression. Next is factor out y plus 3 from the expression. Y plus 3. So that means limit as y approaches 7 is y plus 3 x y 7 all over 3y plus 4 x y 7. Next is cancel out the common, which is the y minus 7. Y minus 7. Next is evaluate the limit. So limit as y approaches 7 is y plus 3 over 3y plus 4. I just put that here. Next is simplified expression. So 7 plus 3 all over 3x 7 plus 4 is equals to 2 over 5, or 2 over 5 or 0.4. And so that's the answer for our first example problem. As limit as limit y approaches 7 and the function y squared plus x y squared plus y 4y plus 21 over 3y squared plus 17 minus 17y minus 28. This is the answer. It's either 2 over 5 or 0.4. So the next question we have here is limit as x approaches infinity of a function 2x squared plus 3 over x squared minus 5x minus 1. So first, let's have to factor the largest power of x in the numerator from each term and the largest power of x in the denominator from each term. So, limit as x approaches infinity is equals to So as you can see from the solution, you can see that 2, the function has horizontal asymptote at y is equals to 2. That's the answer for limit as x approaches as x approaches infinity of a function 2x squared plus 3 all over x squared minus 5x minus 1 is equals to 2. That's it. Thank you for watching.